how do we test a hypothesis about a mean? Now, what makes that difference in the last section is we were testing the conditions that need to be met for a proportion and testing a hypothesis about a proportion. So first of all, let's talk about the requirements. The first one is your sample must be obtained by a simple random sample, and sometimes we abbreviate that SRS. Number 2, sampled values, they need to be independent of one another. In other words, your sample size needs to be less than or equal to 5% of your population. And finally, you need a large enough sample, which is usually, we say, your sample is at least 30, or the population from which the sample is drawn is already normally distributed. The reason why this is important is because we need a sampling distribution, and if we don't have large enough sample, we won't have the bell curve unless the population is normally distributed anyway. Now, for number 1, if you don't have a simple random sample, it could have been also you had a randomized experiment. I almost forgot about that. So this will also work for experiments. Okay, now that you've met those requirements, let's talk about the steps we need to test a hypothesis about a mean. Now, we've already talked about hypothesis testing, so we know a little bit about how to set one up. So we're going to start with a familiar step. The very first thing you're going to want to do is determine your null and alternate hypotheses. So this one's H1. And there's 2 hypotheses, or 2 statements that are against each other here. The first one, your null, will always look something like this, even if you have a different kind of test. In a two-tailed test, we say our null hypothesis mean is equal to some specified mean, or your mean is not equal to some specified mean, mu naught. Right? In a left-tailed test, the null hypothesis looks very much the same. Mu equals some specified average, some mean, but the alternate is less than some specified value. And for the right tail, when you have that kind of test, again, your mu is equal to some specified value, but your alternate is greater than some specified value. All right. Step 2. What you need to do in step 2 is select a significance level. So your significance level is called alpha, and your choice is depending on the seriousness of making a type 1 error. Let's make some more space here. Okay, step 3. What we want to do is compute your test stat. And this is where it gets to be a divergence from our other test. Your test stat this time is a t-score, so we're going to say t0 equals the ratio of x bar, your sample mean, minus your specified value divided by the standard error, s over square root of n. So x bar is the sample average, n is the sample mean, s is the sample standard deviation. Now, once you come up with this t-stat, you're going to use this value, use the test stat and the type of test to compute your p-value. And finally, if p is less than alpha, reject the null. That's familiar. Otherwise, we fail to reject the null. So we never accept the null or reject the alternate. It's one of these two decisions. All right. Keep watching part 2 of this series to see an example